Hey, what's going on, folks? It's Mike here, and welcome to the Programming Language First Impression series, the series in which we look at a programming language for the first time and, well, just try it out, see how easy it is to use, see some of the history of the language, and overall just get a feel for another programming language that's out there. Now, today's language I want to talk about is going to be the Elm programming language. So, I really don't know anything about the Elm programming language, to be honest. I know it's something to do with web applications, and I'm going to go ahead and just switch over to this tab here, because all I really knew of Elm here was, I remember a while ago on the Pragmatic bookshelf, again, not sponsored, but I think they make nice text overall, they came out with this book, Programming Elm, that I would just occasionally see in some of their marketing emails, and I said, interesting, there's a language called Elm, and it sounds interesting. So fast forward several years from this book being published here, and well, I think it's finally trying to try out the Elm programming language. So I'm going to go ahead and just scroll around a little bit. Let's go ahead and do the Wikipedia here and just learn a little bit about the language. Again, this is one that, again, I truly don't know much about here. But if we look at the wiki here, it is a domain-specific language for declaratively creating web browser-based graphical user interfaces. Interesting. Okay, so it's a purely functional language and developed with an emphasis on usability, performance, and robustness. Okay, so these are three things that, well, they all sound good to me. I want my languages to be easy to use and maintain, portable so I can write once and deploy everywhere or to enough platforms, and robust so I can write things, I'm assuming, like safe, maintainable code with fewer bugs over time. So this is already kind of interesting. It's advertising no runtime exceptions in practice. Interesting. So there are a few industries, I believe, in which you don't have exceptions being thrown because it's too costly, or if you're not able to handle that error, that could be a problem. Oftentimes, for instance, in the game industry, it could be costly to throw an exception because it could be a relatively large object. You have to sort of maybe unwind the stack or handle that error. I mean, there's a bunch of different things that could have a cost there. So you tend not to be able to handle exceptions, or they're not advised. I think in safety critical applications too, typically you might not have runtime applications, right? You've hopefully done maybe even a more stronger contract in the programming language. And we've looked at some programming languages like Ada, for instance, which are known for having strong contracts in the language to build very safe and reliable software. And of course, there are things like, of course, Rust, which has various compile time guarantees. So again, you don't have to use or rely on exceptions. So I think that's kind of interesting that is what's being advertised here. So let's just learn a little bit more about the language here. Kind of interesting to see it's just a domain-specific programming language. A lot of the languages that we have looked at have generally been marketed as just a general-purpose programming language, meaning, again, you could write whatever you want, right? You could use, we've looked at D, which is one of my favorites. You could use that for web applications, game consoles, desktop applications, mobile, whatever, C++, Python, etc. All those languages you could write pretty much everything. But this is pretty domain specific and targeted towards web browser based graphical user applications. So this might be one of the more specific, at least as according to this Wikipedia, and we'll find out. Maybe there's other folks writing Elm applications for other platforms here, but it does seem, just looking at this table of contents here, that we have a purely functional language. Again, that's probably where a lot of these guarantees, or if we're talking about things like robustness, come from. Functional languages, because you're avoiding state changes, if you're purely functional, for instance, can often help you build more reliable software. And then for something like HTML pages or CSS and JavaScript, that seems like something that we certainly want. I mean, probably for every application, we want it to be robust and safe, but going a more functional approach might be advantageous. Anyways, let's look at the history here. So let's see. Initially designed by Evan. Let's see. I don't know if I'll be able to pronounce this last name properly. Evan Chaplitsky, maybe. But anyways, let's see. His thesis project here. Okay, that's kind of interesting. Let's open that up here. Reference number 11 here. I wonder if this is like a... here it is. Here is a thesis here. Thank you. Okay, so Stephen Chong, I believe, was at Harvard around this time. Greg Morissette, also around. I think Greg ended up at Cornell. Again, just some of my academic background. I know some of those folks. Interesting here. 47. I wonder if this was I'm very impressed. I wonder if this was a bachelor's thesis. Interesting. This is pretty high-powered stuff, and it's always cool. Let me just go to a little note here, when you get to see, I mean, a lot of theses and these types of things in the computer science world actually kind of do wind up in industry, which is kind of cool. Or you see a lot of the big publications at applied or even theoretical venues. So this is a kind of nice example here, saying something that you would say is research or investigating, and then as that's being researched, it does get developed into something or some portion of it. So very cool. That's a pretty cool outcome here. So that must have been from maybe Harvard or let's see, Morissette, maybe Harvard or maybe Cornell at this time. But anyways, the first release came with many examples, an online editor that made it easy to try it in the web browser. Okay, so we're talking 2012 here. That's around the time where folks are starting to figure out some of these tools like Replit and stuff start emerging and are like nice things. So maybe they got some interesting traction just by having easy to use tools around 2012. And that's something you can always think about from our programming language development. Again, that's part of what this series is about. If you want to develop a language, just seeing some of the highlights maybe, but also thinking about how to deploy the tools, right? We're going to look at the Elm programming website in a moment here. Let's just cue that up here and see how easy it is to learn. And of course, here's the playground here. I'm assuming that we can play around with. So anyways, Mr. I'm going to say Evan, I don't want to Chaplitsky, again, someone can please help me with the pronunciation of that. Maybe I'll go on YouTube and see if he's given a talk and pronounces his name properly for me, so I can pronounce it properly. But okay, they were at Prezi, which is a presentation software, so kind of interesting to think about there. Maybe that's what, I wonder if that's what influenced it here. And in 2013, interesting. So I wonder if, let's do a little bit of investigation here. Prezi, I wonder if they hired him to just work on Elm at the company. That's kind of interesting here. So I would say, again, quite the work that came out of Mr. Evans' thesis here, whether that's a bachelor's or master's thesis, it looked like. That's quite impressive. But let's see the tools here. Okay, so it's targeting HTML, CSS, and JavaScript. And it's continuing to expand, now including a REPL, package manager, and time travel debugger. Okay, that's cool. For some of you who don't know, I do really like time travel debugging. Here we go. I gotta pull in a window here. The second one here, time travel debugging here. You can click on this link here or search, something like this. You'll find it. But that's kind of cool, especially for web applications. And time travel debugging is something that I think Word is just getting about these days. I'm a big advocate of debugging. That's an aside here, but it looks like they've figured out something quite nice here. Now, this is interesting because we're on a Linux platform here. So we've got installers for Mac OS and Windows. That means we might, well, let's see what the update is if this is running on Linux, for instance. But otherwise, we can look at the playground. Either way, we just want to look at the language. So interesting to see that is mentioned as part of their like core developer tools, time travel debugging, along with package managers, which we're seeing with every tool, and a read, evaluate, print loop, which makes sense for web applications because they are probably kind of interpreted, right? Maybe they compile down to some sort of bytecode or assembly, WebAssembly that would make them faster, but that's kind of interesting here. And let's see, they do have a community-created libraries and Ellie, an advanced online editor that allows to save work and include community-based libraries. Okay, cool. Okay, interesting. Let's see, features. We're going to find some of this in the Elm documentation, I'm sure, but things like pattern matching, again, anonymous functions or lambdas, higher order functions, which is what you get when you pass functions as arguments, functions that can return functions, okay, partial application of curried functions, again, so I can pass a function with like 2 out of 3 of its arguments, and then, sort of store that. So that's kind of cool. And functions are called by value. So we're seeing this tick up a little bit in programming languages, I think, because pass by value is just a lot easier to understand. And in some situations, it can also be as performant to just make a copy of something when you're doing call by value. So C, for instance, is a language that does pass by value or pass by copy value. Same thing. Both names mean the same thing, which is kind of interesting. Let's see, immutable values, stateless functions, static typing. Okay, so it's got a lot of these. It's a functional language they're selling us here. But let's try to understand here. Let's see, Elm programs render HTML through a virtual DOM and may interoperate with other code using JavaScript as a service. Okay, interesting here. There's another language, Rock is called, that I've been also looking at that has an interesting idea. I've just listened to it on a few podcasts about talking about it being like a platform as a service. I wonder if that has anything to do with this here. JavaScript as a service. Okay. We haven't looked at JavaScript on this series yet. Maybe it'll come up. Again, it's one I'm a little bit more familiar with, although I don't program in all that often. Okay, so I think we're getting an idea of the language here. There's a module system. Again, it's got an interop, so I guess I can just plug in or maybe inline HTML, CSS, or JavaScript, although we'll find out. It does follow a model view controller. Okay, this is one of the main like architectural software design patterns. Model, the state of the application, view, what you see, and then the update, or this is model view update, I guess here. Sorry, didn't mean to say controller, but update, the function that updates the model based on messages. Okay, I wonder if this is a message passing like architecture. Anyways, okay, so this is going to be kind of core for us to understanding here. How this works here. Okay, so the application displays a number and a button increments the number when a button's pressed. Okay, so you have a label or something that's going to hold some value and display the text, and then a button that you click and it does, plus equals 1 here. Okay, in this case, you store one number. So our model is this here. Okay, interesting. Model is int. Okay, so they're just writing an alias for that new type here. The view function will be defined in the HTML library, okay, with the number and the button. And then you have an update function, which you write here. Okay, so that sets the message to increase, and the increase value is attached to the button defined in view. Okay, and that does the update. Okay, makes sense, makes sense. Let's see what else we got here for this language. And then otherwise, we will dive into the website here. But just want to take a quick look, get a feel of how this looks. Okay, defining a value here for greeting. Type is inferred as a string. Let's see, it's best to add type annotations. Okay, so I guess since it's building, or I wonder if it's just, if this is building web applications, right? The web is built off of JavaScript. So I wonder if this is just generating JavaScript code. So the type annotations, of course, going to be optional, but there must be some sort of, it said static typing at the start here. So at least at the Elm compiler must be enforcing that. Is that correct here? Yeah, static type checking. Good. So it's like a TypeScript or something. Which TypeScript would be perhaps another interesting language to look at in this series. Again, I haven't really used it. I think I did touch it a few times, and I've read some TypeScript code. It doesn't look too much different than, like, I don't know, it's JavaScript with the class keyword and type annotations and amongst other things, I'm sure. So I probably need to study it more, but I wonder how TypeScript competes with Elm and what these two languages have learned from each other. That's going to be really interesting to see here. But let's see here. But this is more of a functional style, though, so that's also a differentiator, which could be, either just an advantage if that's what you're used to versus something like TypeScript, which looks more like JavaScript. Okay, so interesting. Okay, interesting. Yeah, and this is something when we did our OCaml video again. I didn't get into any of the frameworks, but there is Reason here, which is pretty cool for transpiling to JavaScript. I think I'd seen some neat tools, particularly I think they came out of Facebook or Meta at the time here. Anyways, this is the Elm video, so we won't get into that. But interesting to see that there's a few other variations of this. Alrighty, anyways, let's get into Elm here. I'm going to open up the playground because we might be able to try this out. Let's see if there's a Linux installer. There is. Okay, great. Instructions, though. Okay, let's go ahead and see how to get this. Precompiled binary for Linux works on a variety of systems here. Okay, so let's just go ahead and do this then. Let's open up a terminal and just follow the directions here. Oops, let me move my windows around. I'm just going to basically just paste in these commands here. We're going to trust it. Oh, they're using gunzip. Okay. Wonder if I have that installed. All right, enter. Gunzipped. Okay. Give execute permissions to Elm. Okay, so it must be there. And let's move it to our bin. Okay. We'll trust it. Then I can just run it anywhere. Okay, type in my super secret password. Elm help. Okay, it works. If it just works like that, that's a big win in my book. So awesome. Again, especially as a Linux user, sometimes that platform gets neglected. I think less so as the days go by, but this is awesome here. Cool, and we have a REPL here, so this is great. So let's keep that open off to the side here. Let's explore a little bit more of the website here, but pretty painless installation there. That was probably less than a minute or so. And then we got our online editor here, maybe with some examples here. So interesting. Okay, it's the most productive programming language I've used. Some nice testimonials here. The joy and relaxation writing Elm code. That's cool. I really want to spend more time doing my website, so that's one of the reasons I got a little bit curious about this. So interesting. And there's a lot of... oh, Brilliant. Yeah, I love Brilliant. Oops, sorry to click on that. Cool. I mean, so this is being used by some real, companies, which again is something that matters to me when I'm looking at a programming language, because that means there's probably some support, there's some engineers, there's expertise being built and developed, which is useful here. Okay, so no runtime exceptions. Let's see. Yeah, let's dive into that a little bit. That was highlighted on the wiki. Okay, so there's type inference to detect corner cases and give friendly hints. No red ink switch. Switched to Elm about 4 years ago, and 300,000 lines later, they still have not had to scramble to fix a confusing runtime exception in production. Cool. Pretty good testimonial. I would say 300K is a large code base. There are, of course, code bases that are millions and even more lines, so maybe that's number. I mean, that's a significant number to me, though. All right, most folks can pick whatever language you want, 10,000 lines, and in any language, get it pretty concrete over time. But 300,000, that's a pretty significant finding here. Now this is interesting, making reference to 2001 here with HAL. Okay, we'll have to watch that. Yeah, compilers do not have the best reputation. This was written in 2015 by Evan here. So interesting. Okay, this is interesting to see. I mean, we could read about this here, but the type inference and the programming, purely functional programming languages have a little bit of an advantage in how they're structured, and they're structured in this way to provide them this advantage of minimizing state changes. If you're statically typed, you can control for a lot of these things here. And this almost, we don't want to say always, but I'm convinced that this is a good idea for web languages to be more functional. And then you kind of just manage the state with a model view update sort of architecture. That seems reasonable here. Let's see, compilers guides us through safe changes, whether renaming a function or a type. You just follow the compiler errors. Interesting. Okay, that's what they're commenting about. You can understand anyone's code. Okay, sure, including your own 6 months later. This is a big one to emphasize here. I mean, this is part of the robustness argument here. And this is why, it says all Elm programs are written in the same pattern. So it is kind of interesting, languages, for instance, that enforce things like white space. Python's famous for this, right? There are other languages, I believe, that enforce white space, and maybe other domain-specific languages and so on, or even file formats that do. But it's kind of interesting if you get to uniform code and you don't know. I mean, that should be the goal of a very coherent code base. If you're working on with team members and you go through code review, you shouldn't sort of have to know, oh, team member X wrote this code, right? You should just be able to look at it, and everyone should be following the same style guideline, or you run this through like a linter or a refactoring tool. So that's kind of cool here. Yeah, okay, so you can remove all that overhead. It's very interesting from a sort of psychology standpoint, or maybe even sociology, I guess, if you're working on a team, thinking about, how do I remove this stuff so I can be productive in software development? So I actually kind of like that. I don't know. I need to think about that a little bit more, but it seems, at least as I'm reading this, and that's always the goal with having a style guide. Why not have the language enforce it, right? We're trying to make our languages do more these days, as evidenced by this Elm language, to make our code more consistent, error-free, and so on. Okay, so it's talking a lot about the fast and helpful error messages. Okay, so that's great. And let's see, the frameworks. Elm's kicking everybody's behinds here. Lower is better. Yeah, good. I like when people label their charts, or when they're talking, tell me what I should see. And this is a fair chart here, going from 0 to 5,000, so fair enough. Okay, so its own virtual DOM. Yeah, okay, interesting. It's generating fast JavaScript code. Enforce semantic versioning. Okay. That is something actually interesting. I mean, just this is an interesting, just looking at this one keyword diff here and going back to the point above. If we diff somebody's code and it's all written in the same structure, pragmatically, that should make it easier for you to just see what changed in some way, right? There aren't like weird little white space artifacts and these types of things. So anyways, that just kind of triggered that thought. That's kind of interesting. Diffing between code bases and so on. Let's see, but they are using some sort of semantic versioning system here. So I guess if I upgrade a package or something and try to include it, it's going to tell me what's changed here. That's kind of cool. Let's see, they're telling me something changed in like the error handling here. This is the addition, I guess, from just returning a string to like an error code or something. Okay, so cool. Smaller assets. Okay, so Elm does a bunch of optimizations, makes small assets the default. Okay, cool. I wonder if it's compressing the code or something, but this is a pretty significant difference here. I wonder, again, I guess this is the benchmark here. Maybe Uglify or something is a set of JavaScript benchmarks, but that's pretty significant if you're, a third smaller. You're saving on your bandwidth, especially on mobile devices. These types of things matter. So again, cool. Okay, so you can just try it out here with JavaScript. Just good to go. Okay, awesome. I saw a bunch of links down here. So let's look at the docs here. Let's get started here. We've got the official guide here. I want to open up advanced topics just to see what kind of stuff they talk about. Records and concurrency. Oh, interesting. That's going to be interesting. I wonder, because most browsers, right, when I'm executing JavaScript are effectively single-threaded. Now you can do stuff with async and get some improvements here. This must be Evan here talking at the Strange Loop conference, which unfortunately I don't believe exists, but has a lot of high-quality talks, so that's worth highlighting. Okay, cool. So Elms uses a flavor of functional reactive programming, which is in Evan's thesis here. Let's see if we get the correct thesis if I click on this. Oh, it's the same one. Okay. Anyways, thesis was distilled into asynchronous functional. Oh, it was published at the programming language. PLDI is a very good conference, computer science. Just basically a harder to read version of the thesis. Yeah, the thesis, you can have as many pages as you want. Anyways, this is a pretty cool tool here, what I'm finding here, but let's get into it. Let's see the official guide here. Introduction to Elm. Okay. So compiles to JavaScript, helps us make website and web apps, and simplicity and tooling. Okay, let's learn the fundamentals here. Quick sample. Okay. Let's type it out. Let's see how it feels typing, and it wants us to try out the editor here and running this. Let's see here. What's going on here? Just trying to figure out how to best show you folks this. Let's just do it in the editor here. Fair enough. Okay. Let's see what's going on in this code here. I'm going to compress it down just a little bit so you can see what's on the screen here. Maybe there's a formatting tool, but kind of nice to see everything all at once here. Since everything's written in the same style here. Okay. Here's the view. Okay, so if I run this, what happens here? How do I run this? Oh, here it is running, right? Okay, so here is our tool here. This is kind of nice here. So we've got something to increment and decrement. That's what the instructions are. Okay, let's look at the code. We've got our main browser.sandbox. Okay, that's this here. I wonder if this is something that we can just play around with. Okay, we'll have to read and see what these things are. Model, okay. We have an int. This is our data here. It's initialized at 0. Okay. Let's do something like that. Oops, I just hit a random number. Let's see if I do 78. And then there's a little rebuild button I'm going to click on the bottom here. There we go. Okay, there we go. We changed something. That's cool. And then we've got messages equal increment or decrement. Okay, so these are the two types of messages that I can pass. Okay. And when I do update here, okay, I pass a model as an argument and return a model. Again, I've got to practice reading this here, but you know, this is kind of good to look at here. So I haven't, my brain doesn't think functionally, unfortunately, but I'm learning many more things about it. Okay, increment, of course, does this case of adding 1, and decrement does this case of -1. So I wonder, I mean, is this is the pattern match, I guess, and I wonder if there's another like default state or something that you could also add here on your cases. Increment or nothing. Let's try to add something else here. Let's rebuild this. Okay, so if I do that, this case does not have branches for all possibilities. Okay, so we got to add this here. Nothing. Just model equals 0. Whoops, I put a semicolon there. Let's rebuild it. I was not expecting to see this equal sign here. Oh yeah, model. What if I just do 0 here? Okay, now let's see if we could get it to change here. Okay, and then here's the view, which is sort of connecting the model and the update. Okay, on click, decrement, and this is for our button here. I mean, these must be things that are coming from, yeah, we're exposing from the HTML module, button, div, and text, and so on. Okay, so this is our like thing here. Let's see if we added another div here, and another button, on click, and I want to do nothing. Text. Let's see, what am I doing here? Oh, I wonder if this is oh, I see here. Let's just go ahead and refresh that. Oh yeah, I get some nice errors. What have I done here? Just check the syntax. Button, on click, then I'll have a text that needs something, I don't know, 0. Let's see here. Div function expects 2 arguments. Okay, so here's the function with the button, and then it expects 2 arguments. Interesting. Okay. Oh no, I guess I've got to create another view here. Let's see what we're doing here without having any idea what we're doing. We're just changing some code. Model 2. Actually, let's just copy this here. Model 2. View, model. This is one way to just kind of play around with things here. Multiple view declarations. Oh, view 2. Something like that. Cannot find model type 2. These names seem close, though. I mean, this is kind of interesting, just playing around with this. Then we'll actually read and figure out how to do this from scratch here. But just following the different errors here, this is pretty good. It's telling me exactly where the error is. It's telling me some suggestions on how to fix it, and it's giving me a link to documentation so I can learn more. That's pretty much all I can ask for. And I'm assuming I just need one model, and then I just build the thing up from here. But anyways, that's kind of neat here. So we should probably try to learn a little bit about this core language. Okay. Yeah, the code can definitely look unfamiliar at first. Again, that's because most of us don't learn functional languages as a first language. So then we think in like C or Java or something, or Python. Okay, we'll get into how this example works soon. Great. So if we can understand that code, that'll be a big success here. Okay. So what benefits do we get here from a functional style here? Again, no runtime errors in practice, right? Because we can prove things, friendly error messages, reliable refactoring, and automatically enforce semantic versioning. Okay, yeah. So we don't want a ton of libraries where one thing goes out of date and then we just lose all the information. Okay, let's go to the core language. Yeah, let's start by getting a feel for the language here. Okay, maybe let's do this in the REPL. We have Elm here. Let's see here. Core language, values. Let's just type out Elm. Elm REPL. Let's see here. Oh, ELM REPL. Won't be the last time I do this. Okay, it relies on node.js. Ooh, I don't know if I want to install node.js. That starts breaking everything. Let's see if I just do elm. Okay, maybe we'll just do this online. I had a bad incident where I installed Node.js and everything just started breaking. So let's just open up another window here. Close that off. Let's look at the core language here. We could probably just read through some of this. Okay, 1 + 1. Okay, returns value. All the examples are interactive. Oh, okay. Even better. 2 + 2. Okay. And click the up arrow here. Oh, I don't know if I can rewind here. So click on this black box and the cursor should start blinking. Okay. Okay, we've got strings. Okay, concatenation ++. This is an interesting way to actually do the concatenation operator. I see a lot of folks that'll maybe use like the like tilde operator or other things here, but I actually like ++ in differentiating between the plus operator for math. Okay, cool. I like that. I wonder if we can overload these things here. We'll see in the language. Tends not to be something that you see in functional languages, but could be interesting to have. Let's see what else we got here. Plus, divide, plus. Okay. Okay, functions. Transform values. Okay. Greet. Mike. Okay, greet. YouTube. Cool. Let's just call this func. Test equals hello ++ world. And let's just put test at the end here. Okay. There's our function. So we just do func. Yeah, a couple exclamations. Okay, perfect. Perfect enough here. Again, this could kind of be, this is just a functional thing here. Where the arguments are just passed in, and then we're saying, here's a name, here's the arguments, and then you just, do something. Try generating something like Stokely or Kwame. Okay, cool. Values are passed to function are called arguments. Yeah, we know this stuff here. Okay, now the greetings are out of the way. How about a madlib function that takes 2 arguments? Okay. Okay, so you just add more. Of course, that seems reasonable. I mean, this is kind of interesting. I mean, what a difference it is to be using a functional programming language or even learning it for the first time, and then to go to other languages that have lots of state changes. I mean, this reads very clear to me. Even though the syntax is unfamiliar, it is just very clean what this does, and then, the commands that you write out to make use of this. So functional styles are quite powerful, and I'm thinking I like this more for web development here. Right, it's showing you the example, right? All its difference is you can drop the parentheses. But it's nice. They're smart job for whoever wrote this guide here to kind of compare things and say, hey, they're actually, not that different. And it's actually more efficient to just, write out the code without the parentheses. Again, I'm probably always going to think in parentheses, or at least will continue to for a while until I adopt a purely functional language. But that's kind of interesting here. Anyways, let's see here. When you have conditional behavior in Elm, you use an if expression. Let's make a new greet function. Okay. Greet. Okay, well, let's see here. Greet name equals if name Mike Shaw, then hello Mike, else you are not Mike. Let's see if that redefines the function here. Okay, so greet. Let's see, it's going to need parentheses. Okay, can't find the Mike variant. Let's see, naming error. Interesting. Greet. It's interesting if the errors. So that is working here. That's our if else. Here it is. Yeah, interesting that it just can't find the naming variant but it does find the function here. It suggests an import. Okay, interesting. Interesting that it doesn't provide like the number of perhaps arguments or something. I mean, maybe there's a way to improve that, but regardless, still pretty clear here. Okay, list is a data structure that we're going to use here. Hold a sequence of related things here. Again, yeah, this is a typical functional, the one data structure to rule them all, if you will. Then you got some member functions that you can call on it, like is empty, length, reverse, sort, and so on. And then you have map here. Okay, a pretty nice little tutorial here. So let's play around with, again, we're just doing some functional stuff, I guess, here to get us going here. Then hopefully we'll get time to do some HTML stuff. Let's just call this friends. And let's look at the syntax here. Okay, equals. It's going to be the same thing as in Python. Joe, Bob, Jill, etc. There we go. Friends dot, let's see if I tab reverse. Oh, list. Okay, right. This is on a list here. List dot reverse, and then I need to pass in my friends here. List dot sort, and then pass in as an argument my friends. Okay, cool. And then list dot length friends. Okay, simple enough. Simple enough for me. Now, it said earlier on the Wikipedia page that there was a module system. So again, I wonder if list is the module and then these are the functions here, or if there is some sort of object-oriented programming style here. But, overall pretty clean here. Let's see. Oops, where did we go? Let's scroll down here. Tuples we've got. Okay, so we'll use the parentheses instead. That's what it looks like. We can have different types here. Records, we could have structures or structs in C. So this looks pretty reasonable here. Okay, let's write a structure here. Data. Okay, let's say we have a block of data. Header equals 4. Payload equals, testing, something like that. Okay, and then let's create a record here. Now let me think about this here. Okay, so here it is. I guess you just set the header equal to 8, and I see. Data is basically just our record here. So again, just a kind of interesting, again, structure for how we think about these things. If I want another struct that holds this, data 2 or something, I could emulate this. So that's kind of interesting. So here are some shortcuts as well, using list and map. Let's actually use this map thing here. I wonder, does it carry my header on data here? Okay, just as I have it here. List.map. So we're going to access header, and for each of our records, we only have data here. That's pretty neat. Again, functional styles are so concise, it is sometimes truly amazing the things that you could do with it, which is really cool. So anyways, in this example, I was just using a map to access the header of the list of all these things. And map basically is just applying some operation here, which in this case is just accessing the headers of all of our list of data here. Okay, so very neat. It looks like we have some basics of understanding records, functions, and how to create variables and so on in the core language here. Let's see if there's some other examples here just to get into some of the web dev stuff. Let's see here. Oh, if I can just open up the table of contents here. Let's see here. So the types. Okay, we've got the type inference stuff here. And this is a powerful part of Elm here. Again, I mean, it's bolded here. Users do not see runtime errors in practice, right? I'm sure there could be a bug in the compiler or something on occasion, but usually when you bake these things into your programming language, it's going to be pretty solid. If it's enforcing these guarantees here. And they're doing some sort of data flow analysis, it looks like, in the compiler to sort of understand what's going on here. And of course, they're doing the type inference, right? So JavaScript or other languages where you have dynamic typing, I mean, this generates JavaScript code, but again, it's protecting you because you have types for, or at least type inference running, right? You can change some value from holding a string to an integer, and that can cause a mess of problems depending on the context that you're using things in. So again, it looks like it's giving us a lot more enforcement here. It's even giving us these little annotations that we can make for our type here, which is interesting. Okay, commands and subscriptions. Okay, I'm jumping around just a little bit because I want to get into some of the HTML stuff, or maybe running some of the examples here. Okay, we skipped something about handling mouse and keyboard interactions. Maybe we'll just go back here and just take a quick look. Okay, yeah, it looks like we're going to have to read some more of this. I do want to check out the pattern matching here because we want to see what that looks like in this language. A lot of languages are starting to get that feature. Let's see here. Okay, let's go kind of slowly through here. Okay, this is the core language, the Elm architecture. Okay, let's dive into here and see what's going on so we can understand the applications. This architecture seems to naturally emerge in Elm. So let's see. So they basically committed to it. Interesting. Because this just kept showing up. I mean, this is a very common, this is what you're taught in school, model view controller type of stuff for designing applications, or might be taught. But it is very useful for front-end projects. Let's see. So anyways, even if you cannot ultimately use Elm, you will get a lot of using it and internalizing this pattern. Yeah, I believe that. Here's the basic pattern. Okay, so I've got my HTML. Here it is, the little counters. I pass a message, then Elm does something with it, right? It generates JavaScript code to update the HTML or whatever. So Elm program produces HTML to show on screen. The computer sends back messages of what is going on. They click the button. What happens within the Elm program? Okay, we have the model, state of our application, view to turn our state into HTML, and the update to update our state. Okay, perfect. And that's the Elm architecture. Okay, these examples are available in the online editor. Okay, so we might have to just look through some of these. Let's see here, the Elm editor examples, I guess. Let's take a look at a couple of these, like hello. Okay, main text. Okay, so it's got this HTML stuff for just exposing some common labels here. Interesting. Groceries. Okay. Interesting. Show a list of items I need to buy at the grocery. Okay. So these are static HTML pages. We've got a div here. And maybe I missed this part, what this means. This looks like an argument that's just passing in a list here for the div. Now, does the div take two items, like a list for the styles or something? We'll have to just kind of keep looking at this a little bit as I try to understand what's going on here. Oh, cool. There's SVG stuff here. So there's a module here for doing graphics. So you could do little games and that type of thing here, or maybe even big games. Maybe there's some interesting projects here. So SVG. Okay, yeah, these look like the tag properties or something, and then these are like the nested inside regions here. Let's just change some of these here. Okay, it's a little bit larger. Okay, cool. Okay, let's see what else we got here. HTTP here. What happened here? Okay, we got it in a little bit too big of an example, too fast. Buttons for user input. Okay, so this should give us a good example for maybe model view update the model here. I like how there's documentation for all these things too. That's very nice. Let's actually open this up. Let's do a little bit of it. Oh, this is the counter example. Okay, but let's see if we're starting to understand it here. So this is just the type annotation here for the model here, which is a type alias for int. So that's all this is here. Okay, that's our data here. Okay, and then the update portion. Again, we have two types of messages that we can do when we do on click here. Here's our update here with a type annotation. So it's got to be some type of message that can handle this pattern here. for the model and return some other integer here. Okay, so I kind of understanding this a little bit more. Again, it's one of those things I'm trying to explain as I go, but again, you have to internalize some of these things just a little bit sometimes, but it's kind of neat. So anyways, let's just look at some other examples. Upload. So it's got a bunch of stuff built in here. I could immediately see myself just taking this code here and probably generating a pretty reasonable website, just from playing around with these examples and fitting things. In fact, let's just go ahead and mess with that. Let's see here. This is like a nice dice roll game or something. Okay, so sometimes we're getting random numbers here. See if we just kind of stare at enough examples here. This is probably the way that I would start learning Elm, and then I would probably buy that book or again go through this guide again, just to have a little bit of try to internalize the model a little bit here. Again, like model view control makes sense here. But okay, here's a die face, 1 out of 6. Okay, the type here. Oh, underscore, interesting. I wonder, underscore, I'm seeing that in more languages, meaning like it can ignore the value or any value. So that's kind of interesting. It's got a few different meanings in different languages. So that can be, yeah, that's kind of interesting. Let's see, you've got triangles for WebGL. Cool, they're doing a transformation on it. As well, as some of you know, I love graphics, so let's just see what this looks like here. Be interesting to learn graphics programming in a functional language like this. It's not too many lines of code. I mean, that is a nice advantage of HTML. You've got your 2 shaders here. Interesting here. Yeah, this is interesting shader stuff here. You just write a string here. Interesting here. Okay, very cool. This is the first web graphics program we've looked at here. First person. Oh, wow. Use the arrow keys. Spacebar to jump. Cool. Let's see if I can collide into this box here. This is a more involved example here, but it seems they've got it down to a reasonable... How many lines of code is this? 323, right? You can load textured objects. If you can load one and move around and jump or whatever, you're on your way to a game. So very nice. And sorry I'm blocking the view there. But not too much to see here. There it is. It says sample. Okay, let's kind of keep going through the language here. I understand the architecture. I understand, how it's set up and what the language values are. But let's just take a little bit more look at some of the syntax here for Elm. Okay, yeah, for the pattern match. So you declare a type here. Let's see. We can see, okay, regulars have a name and an age. Visitors just have a string, and these are your users here. Yeah, so, I mean, with the pattern matching, these are like, in other languages, again, where I'm used to seeing this is something like a variant, meaning you could have, here's the type, and then you can have different variants of the data, and then you want to have, when you have your case statements, basically make sure that you match every possible condition when you're using this type, whether it's a regular user or a visitor here. So it's very powerful. One, it's great for error checking to make sure that that's actually enforced. Some languages don't enforce that, which kind of defeats the purpose of pattern matching. Or you'll have a case like underscore or something that just is a catch-all for any, case that you didn't think of, oftentimes returning error code or whatever. But that's kind of neat. That's pretty simple to look at. This is pretty clean here. Let's see. What do they have for the wildcards? Yeah, it's just the underscore here. So that might be similar to ML or maybe OCaml. I'll have to remember. That's where I seem to recall doing that in ML. But other programming languages are, using underscore. I think Python even uses it. D uses it. Sometimes it's like a value you don't care about, or either a catch-all. That's usually how it's being used in different languages. Okay. Anyways, let's just kind of hop through this. We're nearing the hour mark here. It looks like there's an HTTP model here. So you can do like GET requests. That's cool. So writing, REST-based applications here seems really, really easy to use. Yeah, I don't know what else to say about that. Otherwise, it seems pretty easy. Let's see. JSON is available, so there must be good parsing tools. I mean, if this is a web programming language, there should be some good JSON or JSON, functions or modules to work with that data. This looks like it's, let's actually look and see if we can find what's going on here. Just kind of scrolling through. Let's see. Okay, so yeah, you have like a JSON decode. Okay, fair enough. And then you can see what the fields are and so on. Okay, simple enough, built in, as would be expected. Okay. Okay, let's just look through a few of these other things. A JavaScript interop here. So you can compile your Elm, which produces HTML by default. Cool. And you can set the output and so on. And if you are doing JavaScript interop, you just want to be able to make sure you generate JavaScript files. Okay. Okay, cool. And then here's like the minimal file. This is probably what all of your projects copy and paste in Elm here. So very nice, very nice. Okay, so very cool. Ports. Okay, to communicate over. Interesting. And there's even a web app section here. I wonder if in the examples, let's just see if we can, I wonder if it had an example here for like a web application. Oh, in the playground. I mean, yeah, Mario. I mean, that's pretty cool here. But how to actually build this into a web app if you want to do web app development. Looks like it's got a way to just, let's see here. I mean, I guess you're just building a single page application. Maybe there's a nice way to bundle them up and distribute them from the compiler here. Looks like it's okay. And then there's other like services you can use to get this running. Okay, seems pretty standard here. Okay, so there's a bunch of optimization stuff here as well. And then our next steps to build something. Yeah, so a bunch of different projects here. Let's click on some of these. This is pretty neat here. Yeah, these are very nice. So, I mean, it looks like the sky is the limit here, honestly. There are meetups here. Looks like there's groups here. I did see an Elm conference. Let me search for that. So let's just see if that's a regular thing here. Let's see here. Elm Conf. Okay, maybe it was held with Strange Loop. Maybe they're discussing here. Looks like it is happening in Europe previously. And it was had been taking place at Strange Loop here. Apologize, I'm a little bit jet lagged today from travel, mixing my words here. But okay, I mean, looks like there's enough interesting Elm stuff going on here. It looks like there'll probably be one in 2024, which is when I'm filming this. So that's pretty cool here. So keep an eye out for that. Again, it's just something that I look at because I want to see that languages, for instance, are active and being developed and so on. There's a Slack and a discourse. The community seems pretty active, so you can get support. There are books. I mean, we saw the one book that I started off with today. In the news here, looks like there's a bunch of stuff going on here. Now, it looks like there hasn't been a stable release for some time. But let's go ahead and see what's going on in the compiler roadmap here. Okay, interesting here. If we go to the compiler, it looks like it's still being worked on, 6 months ago here. There are some updates. So it looks like it's still around. I'm curious about when it's going to hit that 1.0 release version here. Let's see what's on the roadmap. Looks like there are some new ideas that are coming up here. I mean, if you've got a pretty concrete language, the kind of interesting thing about some of these, especially functional languages, you usually see the language. I mean, in the case of some languages like ML, which was a functional programming language, I think it actually just like finished. There were no like language updates or core updates because it was verified or proven that like, it was optimal in some way for like the bug checking or whatever, which is kind of interesting. And I wonder if Elm is sort of in that state. I mean, people are using it certainly, and there are some updates being done and so on. So I'm kind of curious about that. I'd be curious to hear folks who are using Elm to see where it's being used, because it sounds like a really secret programming language. I mean, like React and these types of things are what are taking off in the world. It seems like whenever I look at job boards or talk to students or other folks looking for web jobs that, React is the skill that everyone must learn. But it seems like Elm is a really solid tool. I would actually be curious, and I'm almost convinced to start using something like this for web development, because again, it just seems like it's, if it works perfect and generates JavaScript code that's not going to give me any types of runtime trouble. That seems like a great thing here. So I'm quite impressed with Elm. I'm glad I looked at the language here. It was one totally out of my radar, and the functional stuff is always good to look at, always good to be studying. So I always like to learn a little bit more just as exploring this. And it seems to be a really concrete language. That was cool to see that it developed out of some thesis work and into the real world and production and being used by major companies. So that's really cool. So anyways, folks, with that said, hope you enjoyed this first impression video of the Elm series. Give me your feedback below if you have any questions, comments. I'd be really curious if you are in fact using Elm, if you know about various tools and so on that must be used. We didn't get to the time travel debugger or some of those other things, or the LE editor that was mentioned, but it sounds like there are some really cool infrastructure around the Elm programming language. So anyways, folks, very curious to hear your thoughts on Elm, if you've used it, if you are using it in the real world, what sort of projects and where it is giving you some advantage for some infrastructure that you were using previously. I'd be really, really curious to hear about that. But anyways, folks, as always, thank you for your time and attention, and I'll look forward to seeing you in the next one.